Welcome back, children. We'll continue with the matrices. Here we are going to understand more about matrix multiplication. We have already learned in your 10th standard how to multiply two matrices of order 2. That is, if the first matrix is of order, say m by p, and second is of order p by m, then it is conformable for multiplication. To make it clear, the number of rows is m, number of columns is p. For the second matrix, number of rows is p and number of columns is m. That is, two matrices are conformable for multiplication if the number of columns of the first row should be same as the number of rows of the second matrix. Then you can multiply and it is a third matrix and the product will be another matrix whose order is m by n. M, it is a number of rows of the first matrix and n is a number of columns of the first matrix. We'll do a simple problem from your textbook, example 6c, the second set, fifth question. You have to multiply two matrices. The first one, it is a matrix of order 2 rows and 3 columns. It is of order 2 by 3. Second is of order 3 by 2. 3 rows, 2 columns. So it is clear that the number of columns of the first matrix is same as the number of rows of the second matrix. That is 2 by 3 and 3 by 2. It is conformable for multiplying, or the matrix we can multiply the two matrices. And it is clear that you will be getting a matrix of order 2 by 2. We shall look at. You have already learned how to multiply two matrices. We are multiplying the first row with first column. So 3 into 2. I have written here 3 into 2 plus 1 minus 1 into 1 plus 3 into 3. That is the first element, or A11. Now you have to multiply the first row with second column. 3 into minus 3 minus 1 into 0, 3 into 1. That is A12. Now A22 is, we are going to multiply the second elements of the second row of the first matrix. Minus 1 into 2. Minus 1 into 2 plus 0 into 1 I am not writing, plus 3 into 6. Then the next element is minus 1 into minus 3, 3, 0 into 0, 0, plus 2. So the answer is, here 3 to 6, minus 1 plus 9, then minus 9 plus 3, then minus 2 plus 6, then 5. So the answer is 6 minus 1, 5 plus 9, 14, minus 6, 4 and 5. So in metric multiplication, it is the order, it is clear, 2 by 2. So in metric multiplication, we have to check whether it is conformable for multiplication. That is, the order of the first matrix should be m by p, then the order of second matrix should be p by n. Here p and p, it should be the same. Then the order of the resultant matrix will be m by n. You can refer page number 621. Certain properties of matrix multiplication are given there. The first property is the product of matrices is not commutative. It is not commutative means, you know, if two matrices are the A and B, the product AB need not be equal to product BA. Second property is the product of two matrices can be 0 without either factor being a 0 matrix. The example, it is given there. Please refer page number 622. Now third property, cancellation law for the multiplication of real numbers is not valid for the multiplication of matrices. That is, AB, the product AB may be equal to the product of two matrices A and C, but it does not imply that B is equal to C. That is, we cannot cancel the A from both sides because they are matrices. Now fourth one, matrix multiplication is associative if conformability is assured. That is, if they can be multiplied, then A into B is same as AB into C. Then the last property, matrix multiplication is distributive with respect to matrix addition. That is, A into B plus C is equal to AB plus AC. All A, B and C are all matrices. If A is any matrix, then the product AA, we can define it as A square. We denote by A square. So, if A is any matrix, then the product AA, it is defined only when A is a square matrix, and we define A into A is equal to A square. We denote it by A square. That is the positive integral powers of matrices. So, A square is defined only when A is a square matrix. Now, A cube. A cube is same as A square into A, or A into A square, or it is same as A into A. If we are multiplying A m times, we can write as A raised to m. That is the positive integral powers of matrices only when A is a square. It is defined only when the matrix is a square matrix. And if identity matrix, it is clear. I is equal to I square is equal to I cube is equal to I raised to 4 is all equal to I raised to m also. Matrix polynomial. We can also form polynomials in A. That is A is capital A, that is a matrix. That is for any polynomial. F of x is equal to, the general form of a polynomial of degree n is a0 plus a1x plus a2x square plus etc. n x raised to n. We define f of A. A is the matrix f of A. To be the matrix, it is a matrix f of A is equal to a0I plus a1a plus a2a square plus etc. an capital A raised to n. So to obtain f of A, the small x, it is replaced by the matrix capital A in f of x, and see the constant term a0, a0 is a constant term, it is multiplied by the identity matrix of the order equal to capital A. For example, if f of x is equal to 3x square, I am giving the example in the textbook itself, 3x square minus 5x plus 9, and A is a square matrix of order 3. Order 3 means it is a square matrix of order 3. Then f of A is equal to, I told you the constant should be multiplied by the identity matrix of order 3 and x should be replaced by the matrix A. So that is 3 into x should be replaced by A. 3A square minus 5A plus the constant should be replaced by the identity matrix of order 3. So f of x is equal to 3x square minus 5x plus 9. Then f of A is equal to 3a square minus 5a plus 9 into I3. Children, please take your textbook. Example 33, that is page 625. Refer the example 33. It is given there, the matrix capital A is equal to the square matrix 1, 2, 4, minus 3. 4 minus 3. Find A square. So A square, I told you, A square is same as what? A multiplied by A. You know how to multiply two matrices of the same order. So you find out A square, A into A. So you get that A square. A cube. A cube is same as A into A square. See how they are multiplied? And A cube is given there. Now third question, find f of A. That is what we are learning as new in this chapter. F of A where f of x is equal to 2x cube minus 4x plus 5. To find f of A, I told you, you have to substitute the x. For x you have to substitute A, and for the constant 5 you have to substitute 5y. So to find f of A, the given polynomial is 2x cube minus 4x plus 5. You have to write f of A is equal to 2a cube minus 4a plus 5i. That is what you have to understand. Given f of x is equal to 2x cube minus 4x plus 5. F of A means 2 into, instead of x you have to write a cube, minus 4 into, instead of x you have to write a, then plus 5 into I2. That is I multiplied, the constant term should be multiplied with I2. The other rest of the thing, you know how to find out a cube, So 2a cube is there, minus 4a plus 5y. After the calculation, you get the answer. What is f of it? Is a matrix of order 2 by 2.